Here we're going to look at some power series and some functions and how to represent them as infinite series. We're going to start by taking a look at a simple power series, and then we're going to try and figure out a function for it. So to motivate this topic, I want to look at this power series. Where does this converge? In other words, find the interval of convergence for this. Now we could use the ratio test and do x to the n plus 1 divided by x to the n. I mean, I could do that real quick. I'll do it. I don't know if this is going to help me, but we'll see. So I have that, and I also have, what is that, x to the n times x over x to the n. And those go away, and I just get the absolute value of x. Now this converges, by the ratio test, converges when the absolute value of x is less than 1. So I would then check when it equals 1. Well, I can just do that in my head. When it equals 1, I get a divergent series, because it's just 1 plus 1 plus 1 plus 1 plus 1. And when it equals negative 1, same idea, except it oscillates. Negative 1, 1, negative 1, 1, negative 1, 1. You add them all up, and it doesn't make sense. So what happens here? I know that the interval of convergence is going to be from negative 1 to 1. But I also noticed something. Recall that this is actually a geometric series. We have 1 times x to the n. It's like our c value is 1. Our x is now our r, our common ratio. And then we still have that exponent of n. But we know that this converges to... Actually, if the absolute value of r is less than 1, then this converges to the first term. And in this case, the first term would be c, divided by 1 minus r. Well, in this case, the first term would be 1, right? So we've answered this question already. But I also want to mention that it's a geometric series. And it converges to, so we can say it equals the first term, which was 1, right? Because if we plug in a 0, we get 1. 1 over, and then 1 minus r, but in this case, r is x. So now we have an actual function. If x, the absolute value of x is less than 1. This is by the geometric series form stuff that we have. But now, instead of having an infinite series, we have an actual function, 1 minus x, 1 over 1 minus x. So that's really what I want to point out. This is the most important one right here, so I'm going to put a box around it, and then we'll look at an example. So here's what we're going to do. In your assignment, it says something a tiny bit different, but it's still fairly easy to understand. So write a power series representation of this function, f of x equals 1 over 1 minus 2x. This is actually going to be very, very easy. This is almost the same form, right? Almost the same. Instead of an x here, we have a 2x. So this is the same thing as 1 over 1 minus 2x. I'm just going to put it in parentheses. So really, this is actually the same thing as the sum from n equals 0 to infinity of, well, instead of an x here, we have a 2x. So instead of an x here, we're going to have a 2x. That's it. That's all. So we have 2x raised to the n power. Yeah, so here we go. That's the same thing as the sum from n equals 0 to infinity of 2 to the n times x to the n. And it only converges when 2x, so for 2x, the absolute value of 2x less than 1, which means the interval of convergence, if I divide it by 2, would be the absolute value of x less than, whoops, I'm writing an interval. That would be negative 1/2 to positive 1/2. And you don't include the endpoints because for geometric series we can't have equal to 1. So there we go. There's the power series representation and the interval of convergence. Maybe I should have written that there. In the next video, I'm going to state something that relates to how your examples are worded, and then I'll do another example. Sorry, how your exercises are worded.